Last example of the day is a fantastic example. It's also really, really challenging, so put your mind to it. Make sure that your derivative is at least correct, and then see how far you get with the rest of it. So everybody take the derivative. In taking the derivative, I get g prime of x. I'm going to use the chain rule, so bring down the exponent, bracket to the new exponent, times the derivative of the inside bracket. Merge terms, and I will get 4x over 3, and then x squared minus 4 to the negative a third. I'm going to change how that looks. I'm going to get 4x all over 3, the cubed root of x squared minus 4. Now, notice I have a denominator. This denominator is going to tell me something really, really cool, but something a little bit different than it did last time. So in the first case, I set the numerator equal to 0. I get x is equal to 0. This is a possible maximum or minimum. I'm then going to take the cubed root of x squared minus 4 and set that equal to 0. I get x squared minus 4 is 0, so x squared is 4, therefore x is plus or minus 2. Now notice this isn't where it's undefined like it was last time. It's not a complete undefined. This is something called a cusp, spelled C-U-S-P. Because I'm squaring the x and then cubed rooting it, technically something still exists there. It's just something that I can't take the derivative of. So watch carefully and make your sign table, and maybe you'll see it too. The cubed root of x squared minus 4. I want to put on my number line negative 2, 0, and 2. I'm going to pick the appropriate numbers. So negative, negative, positive, and positive. This is positive, negative, negative, and positive. Take a chance. Look really carefully. Make sure that you're picking the correct numbers and that your signs are right. This is negative, positive, negative, positive. This goes down and then up, down and then up. So there is a potential something at negative 2, something, and then there's also one at 2 something. There is a maximum at 0 something. Now, again, at negative 2 and 2, it is not a minimum. It's called a cusp. And so if I plug in negative 2, I get out 0. If I plug in 2, I also get out 0. And if I plug in 0 into the original function, I get the cube root of 16, which is also a fantastic number. If you want to see what it looks like, graph it in your graphing calculator, and you'll actually notice that it follows the same pattern. But looking really carefully here and here, notice that it goes directly down and then back up again. And then lastly, make sure you put down your levels of increase and your levels of decrease. So it is increasing from negative 2 to 0 and from 2 to infinity, and it is decreasing from negative infinity to negative 2 and 0 to 2. Thanks so much, everybody. Have a good day. Homework will be posted on Blackboard. Make sure you give it a shot. If you have any questions, come in for extra help.